Welcome back, guys. Earlier, what we talked about was how to find out the chemical formula of a compound just by using its name. But we could find that difficult when there are certain ions present, like compound ions, if they're present. So compound ions personally gave me a lot of trouble when I was studying this. So there are not too many to worry about. It's just these: the hydroxide ion, the nitrate ion, the carbonate ion, the sulfate ion, the ammonium ion. We're all familiar with this because we see them as part of different compounds, right? Like sodium hydroxide, calcium hydroxide, magnesium hydroxide, like many, nitric acid, what else? Any, like lead nitrate, copper nitrate, copper carbonate, anything, any combination, like sulfuric acid, blah, 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 right? The problem is not that I forget what these are, but I forget the charge on them. That's my issue. Now, what I end up doing is, for each of these compounds, I remember one of their products, if that makes sense. So before I start with that, hydroxide is kind of obvious that it has a negative charge. I kind of understand that. That's not a problem because you see, I think, hydroxide more often than its compounds, so you know it's negative, so you're very familiar with that. On the other end, you have ammonium ion, which is also, you know, it's a positive charge. I'm normally confused between the three. Now you can memorize them, that's fine, and skip this little video. But if you can't memorize them, my trick is, or how I came to get an A in my chemistry was, I remembered what product they were combined with. So for nitrate ion, I would remember only one product, which was nitric acid, HNO3. Then for carbonate ion, I had calcium carbonate. And for sulfate, it was sulfuric acid, the most common of the sulfates we use. Okay. Now why was that useful was, the nitrate ion over here is bonded to a hydrogen. Hydrogen, we know for a fact, using the periodic table, we can confirm, has a charge of +1. So if it's bonded in a ratio 1:1, barabar ratio mein koi masla nahi hai, so what should be the charge on nitrogen to balance it out? Well, it's going to be negative. So using that reverse logic, I can figure out the charge on nitrogen. Same with carbonate. Calcium is in group 2. Carbonate ka charge mujhe nahi pata. Group 2 hai to calcium has to be 2 plus. Carbonate, no idea, but it has to balance out calcium. There's only one calcium. For that carbonate, the charge needs to be 2 minus. So it's a carbonate ion with a 2 minus. Same story with sulfuric acid. You have two hydrogens with a plus charge each, so a total of 2 plus charge on this entire thing, not the hydrogen, obviously. On the two hydrogens, it's a total charge of 2 plus. On the sulfate ion, it should balance out. So sulfate ion should be SO4 2 minus. So this is another way of, if you can't memorize these charge names, or if you forget often, or if you're in the exam and you're stuck, you forget the charge in sulfate ion, but you remember it's always H2SO4. And maybe calcium carbonate is not the best choice for you. Works for me, but marble, right? Calcium carbonate shows up every now and then. Nitric acid, ye to yaad karna nahi. Like, I have trouble with this even, but I try to memorize like HNO3, HNO3, HNO3. And yeah, that's it. So all these ions, their charges are either are very obvious, or you can find them out. So there's no need to memorize it. But if you want to, if you have no trouble memorizing, that's completely fine. Let's practice some questions. Let's talk about sodium hydroxide. Now, sodium hydroxide is sodium and a hydroxide ion. Hydroxide, I should know or remember that it's negative. Sodium has a positive charge using the periodic table. It's in group 1, positive charge. So they balance each other out. It's NaOH, right? Okay? Sodium carbonate. Now this is what the exam is going to be like. When you're sitting doing the exam, practice ghar mein kar rahe hote hain, you have the charges in front of you, so it's not too hard. But you say, okay, sodium is Na and you're like, I can't for the life of me remember carbonate के ऊपर क्या charge था. Like, is it 2 minus, is it minus? I don't know, I'm not sure. I want to be confident in my answer. If you have that doubt, you can do that logic which I just explained earlier. What carbonate excuse me, what carbonate do you remember? I can always think of calcium carbonate. It just rolls off my tongue. Calcium will have a 2 plus charge, so carbonate will have a negative 2 charge. Done and dusted. You're confident that carbonate is negative 2. So it's CO3 2 minus, right? I'm just putting a bracket there so it's easier to kind of say that the charge is all over. You don't have to put the bracket there. And the sodium has a positive charge. Now, what? I need twice as many as sodium to balance this high negative charge. Think of my way balance again, that tarazu. So it's going to be Na2CO3 twice. No need to put a bracket on there because it's just one ion. It's understood. Okay? I'm going to pause and erase. Alright, let's take a look at magnesium oxide. Magnesium will be, oops, it's not a pen. How do I undo? Alright, magnesium is going to be, it's in group 2, so it has a 2 plus charge, and oxygen has a 2 minus charge. So they're balanced out. It's MgO, and you're done. Some people like to cross, right? Cross the charges. If you're one of those, if you cross these charges, make sure you also simplify it. So it's going to be Mg2O2 with the crossing logic, and after that you simplify it, it's MgO. You get the same thing. Okay? Alright, let's move on to the next page. Alright, calcium sulfate. Now calcium, I know I'm doing this question, I'm just taking more space, I'm writing it next to calcium chloride. Granted. Okay, calcium is 2 plus because it's in group 2. Sulfate, I have no idea. But it comes from H2SO4. H2 means 2 plus 2, right? So this has to be 2 minus. So the sulfate over here has to be I love this app. Wow. Okay. SO4 2 minus. Okay? Those are the charges. They're literally balanced out. Even if I cross it, it'll simplify. And it's, oops, not that. CaSO4. Calcium sulfate. Iske alawa, I think aluminum chloride is like a unique example. Let's take a look at that. Aluminum is in group 3. Anytime now. Right. Aluminum is in group 3, so it has a charge of +3. Chloride, you know it, you love it. -1 charge. Okay? You cross it, or you use the logic where you need 3 times the amount of chlorine to balance this 3 plus charge. Either way, you'll end up with AlCl3. Okay. Now let's take a look at aluminum oxide. I think that's probably one of the more challenging ones over here. Aluminum oxide mein, I'll just copy. Give me a second to erase everything on top. For aluminum oxide, it's Al3 plus and O2 minus. Okay, I should turn my phone off. I should pause this. Alright, sorry about that. So aluminum has a charge of 3 plus and oxygen has a charge of 2 minus. The easiest way to do this is, because it gets difficult, na? Yeah, 3A, 2A, they'll never balance out. So what if I had 2 aluminum? It just gets tedious. The easiest thing to do is cross the values and you'll get the right value, or like the right chemical compound. It's Al2O3, aluminum oxide, everyone. Okay. I hope this helps you guys. I'll see you guys on Monday.